John left. This is the type of story. I think I need that. Oh, for the Zoom. The stories that were typical in that era of AI story understanding. And you can ask it questions like, why did John get a gun? Because he wanted to rob a liquor store. Why did he threaten the shop? Because he needed to get money, etc. And she answered these why questions pretty well. So this was very much work that inspired my thesis work at the University of Illinois. I completed my thesis in 1987. I've been at UT Austin ever since, so my biography is pretty simple. I developed a system called Genesis, which I forget the acronym, Generalizing Explanations of Narratives into Schemas or something. I should remember the whole acronym. And it used plan-based understanding to produce explanations for novel stories and then generalize those explanations into schemas or scripts that could help be used to understand later stories. So I'm not going to read this whole story, but it learned the concept of kidnapping by reading one story, so it's one-shot learning, by taking one example of a kidnapping story, building an explanation for how that plan worked. How was it that John here ended up getting money through the scheme that he developed of locking up Fred's daughter and then exchanging her freedom for $250,000 in money. And it builds this sort of graph-based explanation for how that goal was achieved. I actually use standard. How many people know what strips operators are in AI planning? Hopefully a few people. And it used strips operators and it built a plan for how John accomplished this goal of getting money. He conducted this bargain that had a bunch of preconditions. And then, it had this precondition that Fred liked his daughter's freedom more than money, and that's because he's her father, and so forth. And it had this sort of explanation that it constructed about that story. And that could answer why questions quite well based on the structure of that explanation graph that it constructed. Why did John aim the gun at Mary? So John could threaten to shoot Mary with the gun unless Mary went from John into the car. Notice it's not very good at pronominalization because it didn't really have good pronominalization. I didn't even think I tried to put pronominalization. Why did Mary get into the car? Because Mary wanted not to be shot, because Mary believed that Mary did not go from John into the car that John would shoot Mary with a gun. Why did Fred give John the money? Because Fred believed that if Fred gave John a $250,000 premium, then John would release Mary because Fred wanted Mary to be free more than he wanted to have $250,000. Now, there's some thought that went into restructuring the right strips operators to put into this so it could understand the plan and then use that plan understanding to answer these questions. But of course, if you move to a slightly different story, you need a whole bunch of new strips operators or new actions that you don't know about, and the whole thing was quite brittle. But I think when it did understand, it actually produced a pretty good representation that was really supportive of answering these why questions. Okay, so that's the past. And my own history is deeply embedded in that past, which is why I still care about this problem of answering why questions and building explanations for stories, because it's literally what I did my thesis on almost 40 years ago. So recently, together with the people that I put on the first slide, we put together a large-scale data set of why questions about short narratives, and we had humans provide gold standard answers. I'll talk a little bit about the corpus construction in a minute. And we determined how well large language models could answer these questions. Now, this started a couple of years ago, so some of my results are on older systems like T5, but I will give ChatGPT results at the end. I don't have any GPT-4 results on this particular corpus yet. And we also developed methods for injecting common sense knowledge from existing knowledge bases into these models in order to improve their performance. Because a little bit of this talk is on how we can use good old-fashioned knowledge engineering to actually help language models with some knowledge that they may not have. Okay, and I think why questions are important. This is, we use these stories from this corpus called rock stories. People heard it developed at the University of Rochester. This is one of the stories from that corpus. Rudy was convinced that bottled water all tastes the same. He went to a store and bought several popular brands. He went back home and set them on a table. He spent several hours tasting them. He came to the conclusion they actually did taste different. And then we asked why questions about all the events in a whole bunch of stories. I'll give you the numbers in a minute. But why did Rudy go to the store and buy several plants? A human answered this question saying he wanted to do a taste test. I do believe that this sort of ability to answer why questions and understand the motivations and goals of characters is really critical in understanding narrative, sort of story type of text. And there were cognitive psychologists like Kench that made these arguments back in the 70s, and my academic grandfather, Roger Schenck, with Abelson, who was a psychologist, made these arguments in this famous book called Scripts, Plans, Goals, and Understanding from 1975. So this idea is not new, but I think there's some of these old ideas that really need to be resurrected, which is why I gave this talk at NLP Idle about PAM. But at the time we did this a couple of years ago, there weren't any large-scale data sets on why questions over narrative text. So we built this thing called TellMeWhy, a collection of why questions over narratives. We started with this whole corpus of short stories developed at Rochester called Rock Stories, like the one that I showed you. We asked questions about all the events in those stories to humans. We had 3 human judges on Mechanical Turk provide answers to those stories, like you wanted to taste test. Then to make sure this was quality data, we had 3 judges validate and look at the answer of all these 3 humans and judge, first of all, whether it was grammatical and whether it was totally valid, whether it was a reasonable answer to that why question. So we tried to come up with a paradigm here with multiple judges or producing answers and checking answers to get data that was reasonably high quality. And then we did some data quality check afterwards. Human judges rated 99% answers grammatical, and they said 95.5% were good answers to the why questions. And we got good inter-annotator agreement on making those judgments, like a 0.88 on Fleisch kappa for grammaticality and 0.81 for answer validity, which I would argue is quite high. So, people can answer these questions in a way that other humans agree are good answers or not good answers. So I think this is a pretty good, quite high quality data set. We tried to be sure to help, put in a procedure that would help ensure that. In the end, we collected about 30,000 questions over about 9,500 stories. One distinction that comes up in the results a little bit is we actually asked the Mechanical Turkers who produced the answers, I think, or maybe the ones who judged it, or maybe both of them, whether you could answer the question directly from the text, which we called explicit answers, or whether you had to make some inference that really read between the lines and drew in some common sense inferences that were required. So it's about 30%. You really can't answer from any information that's in any form in the text. You really have to make an inference that goes beyond what's there. And there's a fair bit of diversity. We've looked more in the why questions don't have just one right answer. There are reasonable ways to answer a why question that can be quite different. So actually, there's quite a bit of diversity amongst the 3 answers that we collected. They only have about 26% token overlap between 2 answers to the same question. Okay, so if anyone's interested, this data set is out there. Andrew.
I didn't need to judge.
No, sure.
So discussion with any 11-year-old or maybe 9-year-old, like there are just layers upon layers of why. Like she got into the car because she didn't want to be shot. Well, why didn't she want to be shot? Because she died. Why didn't she want to die? And
so we have talked about
there are multiple
calling that recursive why. So we thought about that. That'd be interesting to actually follow up every why with another why and see how deep down the rabbit hole you could go. But I agree. That's interesting. I think you could build another corpus almost on keep asking why, and then see where people are, eventually stop or get tired of playing this game. But yeah, like I said, why question is not just, it really is a very more subjective, and you can answer levels at different levels of causality or whatever. I mean, what philosophers talk about, what proximate cause versus ultimate cause or things like that, right? I mean, and with actually some of these issues will come up later when I show some examples.
But the data set aims to capture the first.
Basically, yeah. We just asked them once, and but all I'm telling you is we did have humans check the answers, and they all agree, yeah, those are pretty good why answers. Okay. Initially,
So
just
one more question. So you said there are 2 types of questions. So ones that have explicit answers in text, and the other ones where you have to do inference. So how did LLM models, are they worse than the ones where you have to do some inference?
Very good question. Not surprisingly, I will present results that answer that question, which is exactly what you would expect. Yes, obviously, models have a harder time answering the implicit questions. But we'll see numbers up. So a couple of years ago, we started with T5, which at least a couple of years ago was a pretty good, large language model benchmark. I don't know if people know about Unified QA. That's out of AI2, which was a pretty good system at the time. And we fine-tuned those pre-trained models on about 23,000 training examples in our corpus, and then, set some hyperparameters based on 3,000 dev examples. And then as with human answers, we asked 3 human judges to evaluate those answers on about 500 questions that we had hidden that none of the systems ever saw in any stage of training. And here were the initial results, where we just said, well, was the answer judges valid or not by human judges? And we were getting human performance pretty in the 90s. And the models at that time, T5 and Unified QA, were doing pretty poorly, just a bit more than 50%. Here's one of the things I think you're looking at is implicit answers. Notice that on implicit questions, look at those bars. They're even significantly lower than that. So if you really have to go outside the text, these models get quite bad. So fine-tuning large language models, at least as of a couple of years ago, was not good enough for this task. The other point I want to make on this is you really have to do an eval why questions. There's no automated way to test why answers. So we did do some tests. We tried just taking and the normal thing you would do, which is take an automated metric and compare the machine answer to the human answers using an automated metric. And we used all the couple of the standard sort of MT type metrics like BLA, and then more recent deep learning based text math chain methods like BLERT and BERT score. And then we did how well did those automated metrics correlate with actual human judges? And they're sort of a very small, modest positive correlation, but they're not great. It's like what, 0.3 on the Spearman's rank correlation with human answers. So it's not negligible correlation, but it's not of the form I would trust a system just being evaluated on these automated metrics. You really have to do human eval. This means that we have now put up this corpus now for a couple of years. We put in all these scripts that tell you, they generate automatically generate the input to give to Mechanical Turk to run the human eval yourself. Has anyone actually ran this on human eval? No, because people are lazy. They want to run an automated script. They don't want to invest money. They don't want to invest time to do evaluation on an interesting task. They want to do boring evaluations on boring, irrelevant tasks. Sorry, this is my little speech. Because it actually takes some effort. You have to run the actual, Mechanical Turk yourself. We give you all the scripts to make that as painless as possible, but still nobody wants to do it, which really upsets me. Okay. The next thing we ask is, well, what is it missing? What are these large language models that we said are missing? And it's like, well, they're missing common sense. It's like the generic AI person's answer to these sorts of things, right? But some common sense, I would argue, is in these large language models, but they're still missing quite a bit. So is there a way we can inject more common sense into them? Let me skip that. But another question we looked at, obviously, this is now we're up to about a year ago, is does size matter? And of course, we all know size matters, right? So the original T5 we were testing had 110 million parameters. We scaled it up to T5 11 billion, which is already a little hard to run, and not surprisingly, it gets better. But we also tried even larger models like GPT-3, Lambda, and COM. GPT-3 had about 175 billion parameters. There, we couldn't even fine-tune, right? It's really hard to fine-tune these really large models. So we just do them using the classic approach of doing zero shot. Later, I'll present results on few shot. Doesn't seem to actually help on this problem. But size matters. T5 base, oh my God, you go up to 11 billion or GPT-3, it's actually doing quite a bit better. So here I'm presenting a slightly different metric. We actually asked the human raters not just binary, is this bad or good? We asked them to rate Y answers on a -2 to +2 Likert scale. And we found that, these models are doing, the larger models, not surprisingly, are doing quite a bit better. And not surprisingly, on the implicit questions, everything's worse, but particularly the base model doesn't do very well at all. So large models do seem to exhibit some aspects of common sense knowledge that allow them to answer questions that require inferring content beyond the story, but still they're missing something. So we said, how can we add this? How can we add more relevant common sense knowledge to these systems to help improve their performance on a task like why question answering? So we use the system COMET. I don't know how many of you are familiar with COMET, developed at UW and AI2. Where it's an interesting system that combines good old-fashioned knowledge engineering. They collected a bunch of knowledge from humans, but then they trained a transformer on that knowledge to sort of generalize it in interesting ways. So it's sort of a combination of human engineering and machine knowledge. They started with this knowledge base called atomic, and then they trained a transformer to make inferences on top of that. So it's sort of learning enhanced knowledge engineering, you might call it. We also tried using ConceptNet, for those of you who know about that, which is a sort of standard classical AI knowledge-based sort of thing. So, and sometimes you can ask COMET, you can give it a piece of text and say, make common sense inferences from this text, and it'll generate inferences along various types of semantic relations. So here's a story. Another story, Sharon slept right through her alarm clock. She was dreaming of the ocean and how the waves sounded. She didn't even hear her family leave for church. When she woke up and everyone was gone, she was afraid. She couldn't believe they had gone without her. And we asked the question, why did Sharon sleep through her alarm clock? And we give that to COMET and we say, make some inferences based on various semantic relations about why someone might sleep through their alarm clock. And it generates up a number of things. Particularly, it generates this interesting inference: person was in a deep sleep, which 2 of the human answers actually use exactly that phrase, that she was in a deep sleep. And that was an inference that we got from COMET that from the language model without COMET didn't get. So we tried to develop various techniques. I don't think I want to dive into this. Was a EMNLP paper, just this last EMNLP in Abu Dhabi. The details are there, but we tried various ways. It took us a while to get COMET to help these models, but in the end, we did engineer a way to do that. We found that adding the top 3 scoring inferences from different COMET relations worked the best. You want some sort of semantic diversity. So instead of just taking the top scoring inferences complete, we said, we'll try different semantic inferences and take the top 3 amongst that have different semantic inferences relations. So we tried to find high confidence, diverse knowledge. And we found that adding that knowledge to the input story right after the question used to generate worked best for GPT-3, but for some reason it was, so now you know, where do you put that in? The idea is we make an inference from COMET, we inject that information back into the story, and then have the large language model process the enhanced story, the knowledge enhanced story, and then answer the why question. And we actually found that where you put that information can be sent. I mean, all these large language models, right? You change the prompt a little bit, and you know the behavior can sort of vary quite dramatically. We also tried putting it in either in a formal language or in a more natural language form. Not surprisingly, these language models prefer it if you put it in the natural language form. So here we tried to have it has sub-event with all this stuff. And we did some few-shot training examples to get it to learn this format. But we found, not surprisingly, it worked with that if you translate that knowledge into a natural sounding English question. Like Sharon left her alarm clock, ends with she was in a deep sleep, etc. Anyway, the bottom line is we showed that adding COMET knowledge to at least T5 11 billion improved its performance on these why questions, you know, a reasonable amount. It improved T5 base even more, but even for T5 11 billion, adding this knowledge in a verbalized form from inferences in COMET actually improved the average Likert rating of the why answers that it produced. And again, the gains are even better on the implicit questions where we know you have to make inferences outside the story to answer. Now, are we at human level yet? So now we went back and we looked at human, we said, well, what's their average Likert rating? Oh my gosh. We were getting with like GPT-3 with knowledge added to it, we were getting pretty close to the human baseline, which was pretty exciting. But I, being the AI person who's thought about these problems for 40 years, was I totally convinced? No. So I said, I don't really believe this. So let's dive into it a little bit more. So here's the implicit ones. Even on the implicit ones, like even there's a little bit more of a gap, but not much. But you know, I was pleasantly surprised we were doing pretty well. But averages, high information. This is one of the, I think, the interesting lessons I want to give across in this talk, is the average for the large model getting close to you. However, what if we go back to a binary judgment where you say, if the score is positive, you're right. If the Likert score is negative, you're wrong, or 0, you're wrong. And we just binarize. We actually see a gap then. Human answers are given some sort of positive score 99% of the time, where the models are like a 10% gap down to 89%. Well, why is this? Why is the binary score showing a gap when the average Likert score is not? Because the models actually get more +2s than humans, but also more 0s, -1s, and -2s. So they have a more skewed distribution. So let's look, and these are the implicit, it's even a bigger gap for the implicit, right, from 86 to 90. But let's look at the actual distribution of how many answers by humans and different models, mainly GPT-3 or T5 11 billion, are rated a +2. Oh my gosh, the models, only, 44% of human answers, the humans say, wow, that is an absolutely excellent answer to that why question, +2. The models get 52% or 50%. At the top end, they're actually doing better than humans. Superhuman performance. But what if we look at the ones? Now humans exceed, right? They're 55 ones. The models are down to 30% one. Oh, let's look at the negatives. Almost no human answers are rated 0 or below. But the model, 1% of the time, it produces total absolute BS that humans say is crap, -2. Now you average this out, and it looks like the models are doing well on average, but actually they're sometimes kicking ass, and sometimes they're idiots. And this is the same thing for the implicit answers where we know we have to go beyond the story, and we see even more pronounced, I think, differences. And I don't know, really, it's not, but you know, it's still getting these negative scores that humans just don't get.
Yeah, does score of 0 necessarily mean that the answer was inaccurate?
Again, well, here you see the whole distribution, so you make when we binarized, yes, we only treated 1 and 2 as right, and 0 minus 2. Now you could do it, run the analysis the other way. I think you'd see diminished, but still some differences there. So here, this is why I want to look at the whole distribution, and this tells the whole story.
How bad would an answer have to be to get a minus?
I'll show you some examples, but you know, again, we have shown initially that humans agree with 88% Likert agreement. I mean, not 80% Fleisch cap or whatever. So you know, but it has to be pretty bad. So here's some, let's go to some concrete examples. So here's a simply highly rated answer from GPT-3 with COMET. Matt and Sarah, here's where I went back to let's go back to the ultimate versus, what was I saying, the different types of explanation? What proximate versus ultimate answer or something, by explanation. So Matt and Sarah were pregnant. They wanted to announce it in a fun way. They wrote it on a cake. Then they invited their friends over. When their friends saw the cake, they were excited. Why did they write it? The model, which is GPT-3 with COMET knowledge added, says to let their friends know that they were expecting a baby. Well, pretty good. Without COMET, though, they wrote it on a cake. So this is a case where it shows that adding that knowledge in from COMET really gives it some information that allows it to make an interesting inference that makes it produce a really good answer that the model without the COMET knowledge didn't do. The human answer was rated a +1, or one of the human answers was rated a +1, which was Matt and Sarah wanted to surprise their friends with something else. Now let's do the same story, but a different question. Why were Matt and Sarah pregnant? A little bit of a tricky question. The model answers Matt and Sarah were pregnant because they wanted to have a baby. And humans actually really like that answer. This is more the ultimate answer. The humans actually gave the more proximate cause, which is the two of them had they said it really nicely though. Had previously been intimate together. But humans actually like this deeper, more so goals and motivations better than this sort of mechanical, proximate sort of answer. And so the model actually produces this deeper explanation that human judges actually like better. Here's some poorly rated answers to see in the worst case what it does. Maggie was drinking some green juice. She left the cup out a while. When she went to get another sip, it tasted odd. She realized that it had separated weirdly. She threw the juice out. Question, why did she leave the cup? Here's the model's answer. This is even with COMET knowledge even, I think. Maggie left the cup because it was too heavy. It's like, duh? What? Human says, there was something else that Maggie had to attend to for a bit. Notice that really requires an inference that goes significantly beyond what's explicitly stated in the story. Humans are able to do that quite naturally and very easily. The model comes up with this answer that's like, what? And so humans say -2. So this is the cases where the model can really screw up. Okay, so I want to have my new famous quote be, sometimes large language models surprise you how smart they are, and sometimes they surprise you how stupid they are. So my colleague, who's one of your alumni, Niranjan, said, Ray, that's not going to be as popular as your actual famous quote, which I gave at a NACL 2014 semantic parsing workshop, which did become a bit of a meme. I don't know how many of you heard about it. Is you can't cram the meaning of a whole blankety blank sentence into a blankety blank vector. I really said this with profanity. We had a small little meeting at UT, and then I put it in the talk, I put in this fake profanity. And Raymond said, you need some fake profanity in this thing. So I said, okay. My new quote is, sometimes blind talking models surprise you how smart they are, and sometimes they surprise you how blankety blank stupid they are. if people don't know it, actually, Katrin Erk, who's my linguistics colleague at UT, who you guys tried to steal from us as a fascinating, she told me there's actually a name for this thing. Believe it or not, there's a word for fake profanity rendered as punctuation, which is it's called a grolix. This is now my new favorite word. And that obviously was a tradition that started in American comic book, and some comic book writer coined this term. It doesn't even, the etymology I looked into, he just thought it sounded cool. I think it was a he. It doesn't have any interesting etymological origin. It just sounded cool to some comic book writer, and it's caught on. But there, believe it or not, has anyone ever heard of this word? I'm sure not. Before this, my favorite word was aglet. Anyone knows what an aglet is? What is it? It's a little piece of plastic on the end of your shoelace. That used to be my favorite word. Now this is okay. Now let's get a little more modern. I talked up to GPT-3, which is like, come on, GPT-3. This is like ancient history. So they're handicapped because they're zero shot. It's hard to fine tune these models. What about few shot? I'll present some few shot results. And none of this, we tried few shot with GPT, with ChatGPT, it didn't really help. In context learning didn't really help on this problem. I'll show you some results in a minute. More recent language models are more than just language models, right? They've been trained to try to solve the infamous alignment problem, right? Using, I get tired of hearing this acronym now. When I gave some version of this talk, I called ChatGPT the system that shall not be named because I just get so tired of hearing it. But now my new thing I don't want to talk about is RLHF. And there are much larger models that are trained on even more web text, but they are exclusively also extensively trained on human feedback, evaluating their output. I actually found this can make them a little too reluctant to answer why questions sometimes. I'll show you some examples in a minute. And of course, this was all done to solve the alignment problem, to make sure the models align with human goals and produce accurate information that don't cause harm. So, obviously the goals behind RLF or RLHF are extremely important, and it has been a very valuable tool. But it does have some negative side effects in my experience with trying to test ChatGPT on live questions. So it actually, we found this was done a few months ago now, that GPT 3.5, which is basically ChatGPT, it's the API for ChatGPT, even with few shot, our zero shot doesn't really do that much better than just plain GPT-3. And again, if we look at just the fraction correct, actually, the numbers are not that great. So we need to do more studies, and particularly on GPT-4, which I don't know your experience, I actually found GPT-4 can be quite a bit better than ChatGPT.
Does it seem like the performance is going down with more shots?
And that's because of this phenomenon, which is the RLHF, I think, prevents it from making some inferences sometimes because it's being too cautious. So here's an example. I tried this example. This is a classic Schenkian example from the 70s that I grew up with and learned in the 70s, early 80s. John went to a restaurant. He ordered a steak. He left a big tip and went home. What did John eat? When I first asked ChatGPT this, it didn't even know what he ate, right? Now, when I tested it a little bit later, because these things are moving, right? They're not, you run ChatGPT today, it's different than what you were running in the early days, right? But it said it ate a steak, so I at least got that right? But notice that requires an inference beyond the text. You can even argue that's hallucination. ChatGPT, what are you doing? You're hallucinating eating. I never said anything about eating. Why are you hallucinating eating? But some hallucination is the type of inferences that people make very, regularly when they're understanding text. And we don't want to eliminate that. And sometimes I think the RLHF causes it to back off too much and unwilling to emphasize, why did John go to the restaurant? Now it gets all the RLH kicks in. I always do this in robot voice because it sounds more impressive. The story does not provide information about John why he went to the restaurant. And I say, what would you guess his reason was? And the AI language model, the restaurant without further information. However, it is possible that he went to the restaurant and had a meal or meet someone there. It's also possible that he simply wanted to enjoy the ambiance or try out a new restaurant. If you play with ChatGPT, it gives you this sort of crap sometimes, right? It's like being very hesitant. Oh, I don't want to really say, I don't want to get myself. But this doesn't even connect to the facts of the story. It's nice that he ordered a steak. It doesn't even in the stake here. It just perverts to some bland, answer about, politically correct answer about I'm a language model and I can't answer this. Why did he leave a big tip? The story does not provide information. People usually leave a tip as a way of showing their appreciation for good service provided by the restaurant staff or acknowledge their satisfaction with the quality of the food. It's also possible that John left the tip because he is a generous person, or because he received excellent service from the restaurant staff. Again, it doesn't connect with the story. It doesn't talk about the steak, like the steak was probably really good or something. It doesn't even do that. It's just really bland, sort of, I don't want to say anything to offend you sort of answer. And I think this is coming from as a side effect of the RLHF. So I don't necessarily think RLHF is totally a good thing. Okay, now I've given you some examples here where I think the models are being a bit stupid. So let me give you an example that I was shocked of how smart the model was. So this story happened because I was at the MNLP in Abu Dhabi. You said you were there, right? Was anyone else in Abu Dhabi? But they had this reception out and it started raining because they had all these nice pillows and it was very Arab. They had all these pillows and like Arab rugs there. We were all sitting back, relaxing on the pillows, chatting, and it started, believe it or not, in the middle of the desert, it started raining. So and then when I was with my friends who actually did this work, and I said, "Oh, I have a great story to test on ChatGPT." Which actually was something that really happened at that event, at a language conference. I think it's sort of cool. So I said, read the following story and answer the following questions. Ray is sitting outside on a pillow and it starts to rain. He runs under an umbrella. When it stops raining, he returns and turns the pillow over before he sits on it again. Then it starts to rain again, but before Ray runs back under the umbrella, he turns the pillow over again. Why did he turn the pillow over the first time? So I tell people, it's going to screw this up. It's going to show how stupid ChatGPT is. And he comes back and says, Ray turned over the pillow the first time because, no, I'm not using mechanical words because this is aggressive. Ray turned over the pillow the first time because he got wet from the rain. Sitting on the wet pillow would be uncomfortable. So he flipped it over on the dry side. So, pretty good, ChatGPT, but now I'm going to get you. I'm going to get you good this time. Why did he turn over the pillow that second time? You're no way are you going to get this. And Ray turned over the pillow the second time because it had started raining again. And he wanted to make sure that he could sit on the dry side of the pillow again when he returned. By flipping the pillow over before running on the umbrella, he ensured that he would not have to sit on a wet surface again when he came back. It's like, I was like, it's like, I'm a skeptical AI researcher, and this was seriously impressive to me. And I really can't tell you a good explanation, and I don't think anyone maybe can. How was it able to do this? So sometimes I don't want to underestimate it surprises you how smart it is. It absolutely does. It surprised me many times how smart it is. In fact, that's more surprising to me because I expect AI systems to be stupid. They've been stupid for the 4 years I've been working in the field. When they're actually smart, that's more surprising to me. So I don't want to understate that we've made amazing progress. This shocked me how good it is. But it also says stupid stuff too. Okay, so even 3.5 is sort of old news. What about GPT-4? Stay tuned. Yash, who does all the hard work, has been off at internships at AI2, and now he's doing another internship. So I don't know when we're going to get GPT-4 results. What about other types of why questions? We started looking at why questions about instructional text, like say a recipe of how to cook something, and we asked, why did you do this one step before the other? Why did you, preheat the oven before you put the turkey in it? And we actually found that these models are pretty bad at those sort of questions of understanding a plan to the extent that it can give a good answer to why you do steps in a plan in a particular order and giving a good causal explanation for that. But this is initial work. But I have another student who's been working on similar sorts of problems and actually understanding the causal connections between actions and plans. I still think these models are pretty weak at. What about other tasks? We played around with, other people know this data set called social IQA, social QA. Not extra better. It has some related questions, and how well can we transfer from TellMeWhy to other data sets? We've seen some positive results there, but again, stay. Okay, so to wrap up, am I good on time? Answering why question about narratives, I think, is an important and challenging problem. We've developed a large benchmark data set for this task together with an easily developed human evaluation framework. Please, someone take the effort to actually use it. I think it's a fun data set to play with, but you do have to run human eval. LLMs, if large enough, can actually do surprisingly well. I don't want the message to be totally negative here. I was actually shocked a lot of times how well it does. I think I've been pretty clear about that. But, and we've also developed things to try to fill in some of the holes by saying some of these more knowledge engineering approaches like COMET can still supplement what a large language model is doing to make it even more capable. And the best models produce more high quality answers. Sometimes they just, when they get things right, it's like, oh my gosh, that was beautiful. Amazing insight. But sometimes it's just like, WTF, what were you thinking, right? It's like they still can be stupid sometimes, but they just don't have the right piece of knowledge that they've learned from the corpus or to get it. And sometimes it, and that percentage is getting smaller and smaller, right? So I still bet GPT-4 answers some of these questions stupidly, but it's probably now we're down below the 1% mark. It may be like 0.1% of the time it says something stupid rather than 1% of the time. Okay, I'll wrap up there.
So you've talked a lot about why questions. Are all why questions the same? Is there a finer granularity to why questions? Like, are there categories of why questions?
I put in the title here was narrative text. So there are people that work on like, why is the sky blue? Right? I don't know why I would do that. You know, these more sort of scientific type of why questions that aren't asking about human motivations for doing actions. And there's some corpora on this, I think, right? And so I don't think that's why there are lots of types of why. So there are at least two types. Sort of these narrative type ones, why do people do things? And then there's these sort of scientific why questions. I don't know that people have others, but I don't think there's just one type of why question. And certainly our work is just about why questions, about why people do things in stories. And that's not the only type of why question. I think why questions in general, just to be clear, are a very interesting topic. I like this work on these, like AI2 has done some work, because AI2 always cares about science type applications, right? So they've done some interesting work on these like science why questions, right? Which I think are quite interesting too, but I think they are quite distinct. Yeah.
So you mentioned that a very important issue with automatic eval where the Spearman correlation was only about 0.3.
Yeah.
The question is, are there categories of questions that can be automatically evaluated?
Oh, that's a good question. I think we have the data that we can maybe dig into that and see maybe the questions where the answers do correlate well and the answers where they don't correlate well, and try to find a pattern of that. I like that, you know, so I did this work on automated error analysis where we actually run a learning algorithm to distinguish when a system gets right and when it gets wrong. You can run that on this case and actually classify a question whether it will get an answer correlate with humans or not. And then see if you can get any insight from what it learns about how to classify questions that seem to be automatically evaluable and ones that do not. But I like this, it's a very interesting point. Yeah.
You could take the costly manual evaluation of saying, is the human answer and the computer answer similar? And instead ask ChatGPT, are these two answers similar?
Yeah. Yeah, I think there's a lot of, and again, we have the data to do these sorts of things. I think these are both interesting ideas.
All right, I'll throw in one more idea.
Sure.
If you want to evaluate a particular answer to why, imagine you present it as a prompt and then try to evaluate the likelihood of the subsequent story coming after it. In other words, the why is something that leads naturally to the subsequent bit of the story. And so if you something that has a very broad set of following things like Andrew brought up, because I didn't want to die. I mean, virtually anything could come after that. But if it's something specific about the car or something like that, you'd expect the likelihood of the subsequent event to be much higher. So if you
Suzanne, if you put the answer to the why in, the complexity of the remaining text goes down or something, or up.
That's correct.
Yeah.
Correct. Exactly.
Yeah, I mean, again, I think we have the data that you could test a hypothesis like that. It sounds reasonable to me.
And then there's also,
Because if you understand the reasons,
right,
then the subsequent actions make more sense. So understand the intuition you're getting.
right, and then the layers of why, as you go deeper and deeper in the layers of why, the predictability of the story gets lower and lower.
Sure. Yeah.
I actually wonder on the example of the why, where the model gives the overly PC answer. If a human responded with that overly PC answer, you'd say, hey, look, it's okay to speculate and tie it back to the original text.
Yeah.
And so in the
Notice on one of the, I did that, and we all know that if you slightly change the prompt, I was talking to someone earlier here, that if you just add the front of every prompt, take it slow and be very careful when you answer this question, its answers actually get better, right? So, I tried that, I said, we'll speculate, right? And you can get it to go beyond, but you have to engineer the prompt. So when I showed those bad results for ChatGPT, those were unengineered prompts. You just literally asked the why question. I absolutely believe that if you engineer those questions and put a little bit more, be willing to speculate, take a guess, it would get better.
Great. So you're kind of going with where I was going to ask, which is, it feels to me like almost the next layer is to move to prompt optimization, similar to how we moved to hyperparameter optimization.
Oh.
And the question is, in some places we assume what the bounds are to be speculative, in other places not, and that seems to be
There's
missing.
a whole body of work on prompt engineering. I don't know who's the biggest expert in our audience here, but there's a bunch of work on prompt engineering out there. I have not been kept up with all of it, but obviously everybody realizes this is a critical issue. There's all sorts of systems that iterate multiple times and revise the prompt and try to so that that's a whole space. I would say I used to think prompt engineering was that engineers showed up for meetings on time, but it's a completely different meeting now. Yeah.
Just to answer why the model does pretty well about the bed pillow. If you search on WikiHow, there are a bunch of documents about how to drawing pillows and things like that, and what to do when it's raining and things like that. So the model sees.
You just look this up now or something?
Yeah, I just been searching.
Okay. Well, again, this gets to the point that I was even telling my undergraduate students literally in class yesterday is we have to be really careful when we attribute too much to these current models, because a lot of times it's data leakage, right? It's like, it's actually read the exact answer to that question somewhere on the web. And it's like, there's so much stuff that it's been trained on. It's really hard to know whether, I just thought that this was a question that was far enough outside the box that it wouldn't be able to just retrieve an answer, but you might be right. Maybe I needed to search better on the web to see where maybe it found this answer. And you're probably right. But a lot of the way they impress us is they've been trained on just the right data that already answers that question, and they just have to retrieve it verbatim. And there's a lot of studies that show these large language, they do a lot of memorizing of training data. But that's a good point. Yeah, Andrew.
Before NLP was really good enough to be useful, we had to create evaluation data sets because it was the only way that we could tell how well we were doing. When it starts working well, it's already getting used by billions of people. What's the role for artificially created evaluation data sets? Rather than say directly measuring the outcomes from the use by billions of real people getting real data.
These are big questions. I mentioned to several people earlier this morning that if people want to, are not completely bored with me giving talks, I have a talk I gave at UT in January that's up on the web. It's off my webpage called "The New Era of Big Science AI: How do Academics Adapt to the New Reality?" And I try to answer some of these questions because it's really affected your ability to do, I think, relevant, interesting research, because we're in a completely different world. I totally agree with you. But I think what I've come to believe is that I read another paper on this topic, and they say what a lot of academics need to move to is analysis rather than synthesis. So we now have models that do amazing things, and we don't understand how or why they do that. So I think there is a good way for academics to move more into not developing new benchmarks and all these things, but trying to dig. I've never been work on interpretation and XAI for a long time, but I think academics are going to move even more that way, because we can't build artifacts that compete with these large language models being trained by OpenAI and Google and Facebook. But we can do more analysis and dig in deep on some of these questions about why they're doing the things they are. And again, like I said, interpretability is not a new thing. There have been black box NLP workshops for how many years now, like 5 years or something. So people are already doing this, but I think it's going to be academics doing it even more. I agree with you that we're probably going to all have to move more towards analysis and away from synthesis. Yeah.
I was wondering if you had a chance to play with Llama 2, and for Llama 2, they released both the traditional like GPT-3 style model without RLHF, and then they also released
Yeah, that'd be
Llama
great.
2.
So
Yeah.
it's exactly what I'm getting at, and let's do an analysis here where we factor out the RLHF issue. Let's run the exact same model with RLHF and without. And like you said, for ChatGPT, that's hard to do, but for Llama 2 that's open, maybe we can do that. I like that idea a lot, you know? And with open, I'm all about, well, one of the big things I talk about in this talk, I mentioned it's up on the web, is, you know, the value of open models and how we can move, you know, at least some academics being able to work on open models. And I think there are, because you can run these sort of controlled experiments that on these commercial black box models you can't run. So absolutely, that'd be an interesting experiment to run. Yeah, you have a follow-up?
Yeah. The co-founder there is that they released one model with just, you know, the causal language modeling. However, the other model had both the, you know, human preferences and the instruction tuning. So the original model wouldn't have the instruction tuning component in it either.
So, either of you, man. So you're like ChatGPT being too polite. Yeah, go ahead.
So do you think we need to revisit old school approaches like symbolic and logic based? Because those old school approaches were very explainable and explicit and very reliable, but modern approaches with neural models are pretty much black boxes, and they're also unreliable. Do you think there's a way to revisit, for example, the transformer architecture? And
Sure. So anyone who knows me, I was raised in the symbolic AI tradition. I think I've adapted better than a lot of people have. I used to give this talk. I was originally impressed. I worked on video captioning, and I started using deep models for that. I actually have one of the earliest deep model papers using LSTMs using video captioning at ACL, actually. So I was an early adopter in some sense. But I gave this talk for a while. I called, deep, recurrent models for video captioning, or how I learned to stop worrying and love deep learning. Anyone get the reference on this? It's Dr. Strangelove. I had to put the poster up, when I gave the talk to explain the joke. But yeah, I learned pretty early on to stop worrying and love deep learning, but I'm still at my core, I came out of the symbolic paradigm. And so I am a big fan of neurosymbolic, right? How can we synthesize? I had a nice discussion with Chris Manning and some younger grad students at ACL in Toronto this summer, saying that, and Josh Tannenbaum has done some interesting work in this space, but he also gave a nice invited talk at ACL, not this past year. Josh gave an invited talk at ACL like the year before or something like that. And he made it this way, which I agree with, is in AI, over my lifetime, we've sort of experimented with three fundamental paradigms: the symbolic logical paradigm, the Bayesian probabilistic paradigm, and the neural net sort of paradigm. And I think I at least have learned a lot about AI I've worked in all three of them actually over the years. And I think I've learned a lot by viewing AI through the lens of each of those. And I think they all have something to offer and some insight and understanding about how to build cognitive systems and also understanding human cognition. And I think we do need to move into more of if there's any synthesis, is how do we actually synthesize all the insights about AI that we've learned through all these paradigms into the next generation of systems. And so, yeah, but there is a lot of work. There's all these workshops on neurosymbolic and things, but I am a big fan of trying to integrate all of these insights. Like I said, explainable AI, interpretable neural nets. I mean, these things are they're black boxes until you dig into them, but you can actually turn them at least a little bit gray if you just analyze them. Yeah, you're very patient.
Yeah, I noticed that the stories in this data set are very short. The other experiment with longer.
Yeah, that was a very good thing. I remember I was talking, I think it was like this last summer, we were talking about Mohi's work on summarizing novels, right? Oh, that's right. Okay. Well, so I understand why you're asking this question. I think it's a great question. Yeah. So again, that was the old Shank tradition, like 4-line stories. Rock stories is very much in that paradigm. Oh my gosh, I think this problem becomes much harder if, you have it read Anna Karenina and then ask why did she have an affair with some, person, I don't know, whatever. I think doing this, but oh my God, this is hard enough, doing that at book scale, doing live questions at book scale, great idea, pragmatically seems really hard to do. Yeah.
So just to put it out there is a dataset narrative QA that has
Okay.
some why questions at that.
Oh, I didn't know that data, so we did look at that, there's not a huge fraction of why questions in that data, but that's not on books, right, that's still on short stories.
It is on
Well,
yeah, I think it's on summaries of books as well.
summaries
So you can do it on summaries.
are the whole book. Yeah, I mean, I think all these are good directions, I just think they do get pragmatically sort of hard to do.
Yeah, maybe I'll ask the last question.
Sure.
I just wanted to follow on to Andrew's question, because I think one thing that a lot of us are worried about now is this, if you make a new data set, there's this big risk of OpenAI or Google or whatever, including that data set in their training data. Your data set could
It could
presumably
be in there now, yeah, I
so
don't,
then, like, you know, if you wanted to analyze it on any black box model, you just don't
yeah,
know, right?
No,
Do you have
absolutely.
any, thoughts?
yeah, I agree with the problem, do I have a solution to it? No, I mean, yeah, as I was saying, this data leakage problem is becoming really tough, because these models are sucking up everything that's out there. And
if
so
we-
the only answer I would have is stick to an open model where you know what it's been trained on, and this gets a whole question. I actually had this discussion with my colleague Naranjan, right, who again is one of your alumni, about he said how IR adapted to the era when Google came out, right? Whereas like now, it was not expected that academics and IR would always compare all of their results to Google because it was this big giant behemoth black box. And so I think we do have to, and as reviewers, we're responsible. I mean, I've wrote these reviews myself. Wow, ChatGPT flew you on this problem, and maybe we need to back off of that and say, if you're you cannot ask someone to test on a closed model. That's not I'm not saying this is my position, but I think it's not an unreasonable position to say that we're not going to accept any paper with any results from a closed model, because we don't know what that is. We don't know what it's trained on, how many parameters is. It's easily to get data leakage. I'm not saying I support that view, but I'm somewhat sympathetic to it, because we're in a really weird space right now where maybe it's getting all these good results because it's just seen all the data before. We really don't know how. I was just telling my undergrads the other day, I call it the prime directive of machine learning. What's the prime directive of machine learning? Do not test on your training data, right? And I tried to talk about what was the prime directive in Star Trek. They don't know about Star Trek. I don't understand it. But yeah, and we can't directive anymore because we don't know what the training data was. And we can't avoid it. That's a really serious fundamental problem.
Why don't you keep the data set secret? Just have like an automated system like Kaggle, right? Where
Yeah, it's a fair point.
you just don't tell them the data if you won't.
Yeah, we built this thing 2 years ago when this problem wasn't as pronounced as it is now. But yeah, I mean, I think there is going to be more need for just totally hidden test sets that aren't available on the open web.
Okay, let's
Okay,
thank
thank
you.